Circular queues. As mentioned in a previous video, queues operate like single file lines. That's because the first value to enter is always the first value to leave, and every value added after that is simply in place at the next empty slot. This allows insertions to be done rather quickly. Dequeuing elements, on the other hand, will take relatively long because whenever I remove the first element, each element after it has to be shifted up one spot forward, thus making it a long process. Circular queues make this process short by first keeping track of the index of the front value and the back value. Now note that with a regular queue, the front value is always going to be at index 0. With a circular queue, however, that's not always the case, and here's how. Now suppose I add an element to this queue. I add 37. Just like with the regular queue, I place it at the next empty slot, then I update the back value to be 5, because that's now the current index of the back value. And I continue that whenever I add a value to the queue. Now suppose I want to dequeue a value. Do I need to shift the values forward? No, I do not. I simply increment the front index to let us know that the current front value is at index 1. And I don't have to worry about the 15, the value at index 0, because the circular queue is programmed to not pay attention to any value that's not within the range of the front index and the back index. And I suppose I want to dequeue again. Once again, I simply increment the front index to let us know that the index of the current front value is at index 2. Now, consider this scenario. Suppose I want to add 3 more values to the queue. Okay, I add the value 2, add the value 99, and now I want to add 74. However, we're already at the back of the array. If this were a regular queue, anytime we reach the back of the array, the next insertion would require us having to expand the array, allocate a new array twice the size of the current, and then copy all the values to that new array before adding the next value. However, in this situation, that is not necessary because although we're at the back of the array, we still have 2 unused values at the front of the array that we can use. So, what we're going to do is wrap around. We're going to store 74 at the front of the array, setting the back index equal to 0. And then the next time we add a value to the queue, once again, we continue as we were. We simply store the next value at the next empty slot and increment the value of the back index. Now, the next time I try to add a value, now we have to expand because there's no more empty slots available. Only in this situation do we allocate a new array double the size of the original. Then we copy all the values from the original array to the new array, starting at the front index. So we're not going to start at index 0, we're going to start at index 2 and copy all the values after it, including the wraparound. After all of these values have been added, only then do we add the next value 80 at the end of the array.